Let's get today's program started. Without further ado, it's my absolute pleasure to welcome and introduce Brian Hopkins. Brian, over to you.
Thank you for that introduction, Joyce, and really happy to be here today and happy to talk to you about this concept of edge, specifically a buzzword you probably have heard, intelligent edge. And so what I want to do today is give you some information that we have in our research about this term, what it is, and our assessment that it's more than buzz. It's becoming a reality, but it's not quite a reality yet. So let's get into the material. So the first thing I want to do is kind of show you what our data says about edge. And this is an interesting survey that we ran last year where we asked quite a number of clients in our business technographic survey what they thought about edge and what they thought the most important use cases were for edge. And so I know you're probably going to squint at this a little bit, but I wanted to highlight the first three answers. Those are the ones you should pay attention to, right? Which of the following do you believe is the biggest benefits to your organization using edge computing technologies? And I was actually quite surprised by these answers. So number one, flexibility to handle present and future artificial intelligence needs. Number two, collection and AI analysis of edge equipment helps us empower employees. So it's about employee empowerment for tangible assets. And third thing is collect inputs from mobile, IoT, and other devices to help us provide customers with real-time insights. So if you think about those three answers, what is edge about? Why do you and the other clients we talk to, why are they interested in this concept? It's implementation of artificial intelligence and machine learning for employee and customer insights in real time. That's the reason for edge. So let's keep that in mind as we go a little bit deeper into this. So the next thing I want to share with you is a trend that I wrote as part of the research I do every year on our top trends and emerging technologies to watch around edge computing. And I've included the summary from the report called At a Glance for you, because I'm assuming this content will be distributed to attendees. And you can read that at a glance. But let me just summarize to you kind of what the trend is in terms of past, present, and what we think is going to happen in the future around edge. So in the past, edge was primarily, when we talk to clients, associated with IoT. That is, with the connectivity of things and people in specific operational environments, Industry 4.0, predictive maintenance, and traditional kind of IoT asset management and logistics use cases. That's where edge actually grew up. And there's been a lot of edge computing there with like PLC systems for a very long time. So in that context, it's not all that new. But what we've began to see happening and what's happening today is that we see the expansion of the use of word edge by a lot of different vendors for different scenarios and use cases. And I'm going to go into some of those and give you examples. And at the very end, I'll actually give you a very detailed slide for you to reference later about kind of what some of the use cases are and what some of the vendors are in that space. So we're seeing a lot of vendors jump into this idea of edge. And we're also seeing quite a bit of innovation at the intersection of advanced networking driven by 5G and like virtual networking and edge computing. And there's a lot of innovation happening there, and I'll give you an example in the few minutes we have. But what this really means for the future is that firms whose cloud strategies today are primarily focused on implementation of more and more in various hyperscale public cloud vendors, and then connecting those back to what's happening in their data centers, i.e. hybrid cloud. We think that there's a lot of technologies, and we'll talk about a few of them in a couple slides, that are actually driving and will drive firms to consider their cloud strategy not only to be data center, not only to be public cloud, but also to include edge computing, right? So we think companies are going to really expand their cloud strategies to include edge over the next 2, 3, or 4 years because of this. So let me give you an example of that. So this is from a research report that I helped some colleagues with, where we looked at use cases between IoT, 5G, and edge computing. And this particular one was very interesting. It's with Rush University Medical Center in Chicago. And what they did is they partnered with AT&T to use their 5G network in what we call private 5G. So in private 5G, what happens is the telecommunications provider will come into a location like a medical center and install the millimeter wavelength and all the infrastructure needed so that locally within the context of that location, their employees and their customers in that location have access to 5G, and they'll run that on a private basis. So what we see with the private 5G is we see private 5G then enabling through the telecommunication company's edge strategy, which is also called multi-access edge computing, or MEC, the enablement of new use cases that were difficult or hard to do prior to this. So things like simplifying real-time assessment of patient status, assisting nurses and doctors with real-time patient assessments by processing patient or patient local area network data. Different kinds of edge applications, processing medical imagery and providing insights to that medical imagery in real time. Those kinds of things that were very difficult before are all things that Rush is experimenting with now, right? This is a lot of experimentation, a lot of pilots, a lot of seeing what's possible as these technologies intersect. So that's an example of some of the things happening today because edge computing is enabling more real-time intelligent decision-making, right? But let's talk about the reality, because you'll hear this word intelligent edge from vendors a lot, and it sounds cool, and it really reflects the data that I showed you at the beginning of the presentation, which is the real interest for edge is the use of machine learning and AI for employees and real-time customer experiences. So what I'm showing you here on the right is a whole bunch of different logos from some of the different software efforts. Many of these are open source that are all kind of circling around this idea. And anytime you see a lot of open source, it's the indicator of some real innovation going on. It's also the indicator of a lot of complexity. So what we think here is from the examples like you saw from Rush Medical Center, the potential is there, specifically as edge computing becomes enabled with next generation networking and 5G. So there's definitely the potential, and we see that. The problem is the engineering reality of what's possible. How can this really happen? What's it going to take to realize the value is not really there yet. So what that really means is, like I said, we see a lot of these projects, Kubernetes plus TensorFlow or Kubeflow, Kubernetes, which is a code portability standard around containers and Docker containers. KubeEdge is Kubernetes plus Edge. So Kubernetes plus AI, Kubernetes plus Edge. These open source projects have a lot of potential for driving edge intelligence, right? Lightweight Kubernetes, something called K3S is another one. There's projects from Intel, OpenVINO for enabling running artificial intelligence and machine learning models on different kinds of chips, different x86 chips, different GPU and FPGA chips, and all the things that you need to actually run a machine learning model. For instance, an image recognition model in a video camera. Project Cassini, which is an ARM project for the ARM architecture, doing some similar things on standardizing how you run business rules and machine learning models at the edge. And then there's this whole idea of federated machine learning and how do you train machine learning models where you're not having to send all that data back to the cloud. All these are very complicated, right? There's a lot of things going on. So one of the things I always do to kind of gauge the maturity of a particular emerging technology and a trend around is I go talk to the startups and I say, what are you doing in this space? Because startups, unlike other vendors, are always laser focused on the business value because they're not delivering the value. Their investors aren't investing. They're not getting to that next round. And so therefore, they tend to be very pragmatic in their use of artificial intelligence. And one of the things I found in talking to startups about edge and machine learning and AI is most of the startups have that on their roadmap, and it may play into their marketing materials. But when you ask about how they're solving problems for customers today, it's not necessarily using all these advanced edge machine learning things. It's really doing very pragmatic things with edge computing and very pragmatic things with IoT, with these things on their roadmap in the next year or two or three, which is what tells me that today, this is a lot of potential. There's also a lot of engineering problems to solve. Two main issues I want you to remember. Issue number one, how do you enable artificial intelligence or machine learning inference model performance on a heterogeneous hardware environment, where you're running that model on different kinds of chips, different architectures, different networks? That's a very, very difficult problem to solve. right? So that's problem number one. Problem number two that we see being worked on is how do you train models in a distributed way? So those machine learning models don't require an enormous amount of unstructured video data to stream back to the cloud where that model's being trained. How do you do that? That's another very tough engineering problem. It's going to take a while to solve those things. So the takeaway from this slide is the reality of intelligent edge today is a lot of potential, a lot of innovation and pilot work, a lot of hard engineering problems to solve. Another thing that I kind of gauge where something is, not only from what the startups are doing, but how are the 800-pound gorillas of information technology as the cloud vendors, what are they doing and where are they going? So you look at Azure and AWS and Google and Alibaba, right? Where are these companies going? And one of the things that we've noticed over the last 3 or 4 years is cloud vendors are accelerating their partnerships with telecommunications vendors and enabling more and more edge capability, each with their own different strategies. So that's kind of another thing to think about that we really don't have time to talk about today, but each of these cloud vendors have different edge strategies. AWS and Microsoft have a very hardware-centric converged approach to enabling their cloud solutions in different edge environments. Whereas Google, along with a few other vendors, are taking more of a software-driven approach using Kubernetes and things like K3S for lightweight Kubernetes and some of these open source projects where you can deploy software into many different edge environments without a hardware dependency. So that's a huge difference in strategies that we see happening. And it's going to be real interesting to see which one of those play out. We really don't know what's going to happen yet. But there's a lot of energy in the cloud vendor space on enabling the opportunities that edge plus AI enable. So the final thing I want to go through here with you just for a few minutes is when clients come to me and they say, what is edge and how do I enable this edge AI thing? The first thing I always, and usually we never get beyond this, is there's actually, we think, not one edge. And that's the first question you have to ask is, what edge are you talking about? Because there's different solutions and different vendors, which I'm going to show you on the next slide, playing in the different edge spaces. So what I'm trying to show you here is a diagram that I haven't even published yet. So this is fresh, hot research. This is going to come out on our website within the next few weeks. And that is there are 4 edges to edge. So when we think about the 4 edges of edge, you want to think about the relative position between the core enterprise IT assets that's on the right and different remote business locations like shopping malls or cruise ships or entertainment venues or logistics centers or manufacturing plants, right? So when you think about those differences, you have the core edge and then you have places where business is happening, where your employees and your customers are doing the business of your business together that are beyond your core enterprise assets, whether they're in the cloud or in your data center. So the edges that we see coming out from that, first we have the enterprise edge. So in the enterprise edge, that's an extension of the assets, your ERP systems and your customer experience and your mobile engagement systems that you were running in the cloud or in your data center. Those things are now, in some cases, moving out to other vendors' data center locations. So the co-location vendors like the Equinixes of the world are using the word edge computing to mean enablement of those core assets outside of your core data center or the cloud in connected ways so that you can move your processes in the software closer to where business happens to be happening, whatever region of the world it happens to be happening in. So there's the enterprise edge. And then moving to the left beyond that, there's 2 kind of stacked edges that are happening at the same time. The operations edge is really about typically what we think of IoT use cases. It's remote locations where your business is happening, where your employees and perhaps your customers are coming together and doing the process of your business, whether it's making things, selling things, delivering services, right? It's that kind of thing where that centerpiece of the operations edge is operating your business at a specific location. The other edge is what we call the engagement edge. And the engagement edge is a different kind of thing. Engagement edge is where vendors are using, like content delivery network vendors, are using their global points of presence, which they have clusters of compute all over the world, connected together, and then they're enabling software in that compute to allow customers to deploy components of their system of engagement applications, their mobile applications, in ways that gain much higher performance because the software vendor chooses where those software components run, wherever you need them to, wherever they are in the world, right? So that's really extending this global customer engagement thing that we began to understand we needed to do when we had to make mobile applications perform. And now we're extending that to run software that's just not about mobile applications. So we have Engagement Edge and Operations Edge to some extent kind of connecting to each other. We have Enterprise Edge, and then those are all being served by what we call the Provider Edge down at the bottom, which is what the telecommunications companies are doing to enable running different edge use cases on their infrastructure. And those edge use cases include Enterprise Edge, Operations Edge, and an Engagement Edge. So that's the first thing I do when I talk to clients is I say, which edge are you talking about? And the reason why that's important is because the use cases and the scenarios and the vendors tend to be different in these different use cases. So I'm almost done here. The last thing I want to show you, and I'm going to warn you, this slide is going to be an eye chart. You're going to need to stare at it after we're done. So what this next slide does is it's going to take these 4 edges, it's going to show you some use cases and vendors, and it's going to give you a couple of other classes of horizontal type vendor solutions that support all of these edges. So you ready? Let's look at this. Here it is. So if you'll notice, the structure is the same. We have the enterprise core, we have extended enterprise, we have provider edge, enterprise edge, engagement edge, and operations edge. So the structure is the same as the previous slide. Now what I'm showing you, though, is some of the vendor logos and some of the common scenarios or use cases that happen in each one of these edges. And at the bottom, I give you some horizontal platforms in terms of edge management and hyper-converged edge infrastructure that enable one or more of these use cases. So again, under Enterprise Edge, we see things like office automation, smart buildings, software-driven wide area networks, employee engagement solutions, right? They're an extension of what you do today in your data centers and in your main headquarters, right? So moving to the left, we have Engagement Edge. We talked about those vendors, things like Axion, Akamai, Fastly, CenturyLink. AWS is in that game too. They have their own content delivery network. And those are things like streaming video, of course, smart home, smart security, smart speakers, consumer virtual reality, gaming, remote camera, IoT data processing. Engagement Edge vendors are focusing on those things. Whereas if you move down to Operations Edge, you have things like industrial automation, supply chain automation, logistics and transportation, local area sensor networks, and the like, right? So there's overlap between those two, but you see the Engagement Edge are focused globally, and the Operations Edge are focused on specific locations and the things that are happening at those locations, all supported by the Provider Edge, right, which is a bunch of open source projects that all the telco vendors and their partners are working on to enable these other 3 edges. And down at the bottom, you have edge management platforms, which are software platforms from vendors like IBM and Rancher and Google Anthos and VMware Tanzu that are enabling edge as a software across many different hardware environments. And then the last thing you have is edge hyperconverged infrastructure, where it's the software and the hardware in a box, and you can deploy that box anywhere that you need these edge kind of capabilities. And each has its pros and cons, and there's kind of a big battle going on in the industry right now around that. So in summary, I want to wrap up here and thank you for spending this few minutes of time with me. I hope you have lots of questions for our Q&A, but I just want you to remember what we talked about, right? Edge is important, and edge AI or edge intelligence is the reason for edge. And there's a lot of innovation happening in the space, but it's still not there yet, right? We can't expect to solve some of the really hard problems. We talked about distributed or federated machine learning. We talked about running machine learning models in many different places, right? Using in a heterogeneous environment, how those are really hard. Then we talked about the 4 edges of edge. We talked about how that edge computing would become part of your cloud strategy. And we talked about the different scenarios that you need to think about when you're kind of planning the use cases you're going to go after in the different 4 scenarios and the types of vendors that serve those use cases. So I hope this has been very useful, both introducing the topic of edge computing, giving you some examples, and giving you some of that gritty detail that help you plan out your edge intelligence strategy. So thank you very much.